All right, question number 51. A man pushes a car along a road. He exerts a force F on the car. What kind of car is this? It's like a Renault. Okay. Um, in this situation, oh my gosh, are you kidding me? See, we finally reached it. I think we're finally repeating concepts over and over. We want the third law situation. So, person pushes car, the reaction force is going to be car pushes back on person. So, choice A. Look at all these distractors. There is no reaction force. D is just a complete mess. Don't trust that. Okay, so person pushes car pushes back on person, which is A. All right, 52. Okay, this is the classic situation. This person is moving in a circle. Ignore your intuition. Okay. There is a force directing this person towards the circle. So there's the force directing them towards the center of the circle. There is a friction force pointing up. This is the reaction force from the wall, the normal reaction force, and then there's their weight moving down. The choice B. A lot of people want to choose choice A, so I just want to say one more thing just to be clear. Okay, ignore your intuition, which says there is a force sticking her to the wall. Okay. It's a force pushing them in a circle. Okay. That's the idea. All right, question 53. One block is dropped from the ground while an identical block slides down a slope to the ground as shown in the figure. They start at the same height. So let's be clear. If they start at the same height, that means we need to eliminate all choices that say the speeds would be different. However, when we compare times, look at the length of the path here versus here, they're going to have different times. This will take a longer time to accelerate, but when it finally does get down here, it'll clock at the same speed as this one when you just drop it. All right. A car and a truck with equal speeds in opposite directions collide head-on. The truck is more massive than the car. This is a weird way of looking at the third law, but let's be clear. So F on the car due to the truck equals the force on the truck due to the car. And let's be clear, if the forces are the same, then the impulse is the same. That's how we actually get conservation of momentum. So what this means, since impulse is the change in momentum, we're going to have equal and opposite momentum changes. So that's a little bit of a variation on the impulse momentum theorem for 54. 55. Whoa, okay. Well, look at all this math, density. Okay, let's look for the saving grace. How many significant figures? 2 here, 4 here. Oh, good, 55 is just good old B. Don't even do the calculation. Don't even try to reason out the calculation. You look at the number with the smallest amount of sig figs, and that's going to be your answer. All right. Rectangular plate. I don't know if you remember how to get percentage uncertainty in areas when you multiply, but it's going to be 1 over 50 plus 1 over 25. So when we do that, that's going to be 2 over 100 plus 4 over 100, which is 6 over 100, which is a good old 6%. All right, 57. Orbital period, solar system. So this looks like a Kepler's law question, like, oh gosh, he put new stuff on there. Nope. What variables do we plot to get a straight line graph? This versus that. Don't even trip. Just keep it simple. Now here. A body on a smooth horizontal surface attached to 3 spring scales. So how do these forces compare? Well, we know that these lengths are the same, so these forces are the same. So we're going to have Q and P and Q the same, and R is going to need to be bigger since these are both components of it. So What that means is that Fr is going to be bigger than these two equal forces, which is choice B. And 59, identical stones are dropped simultaneously from different heights. Air resistance is negligible. They're going to cover the same distance in the same amount of time as they fall, since they fall at the same time. So their distance will actually remain the same. Now, slight variation. We now throw Q down at a greater speed. So P launches up into the air, comes back, going downwards at a speed less than Q, which means Q is still going to hit the ground with a greater speed. So that's question 60. Like I said, I'm picking up the pace a little bit only because of repeating concepts, and that's going to kind of continue as we go through the videos.